Good afternoon. I know that it's too late, and in order not to stick you here for a long time, I will start this final and conclusion plenary session. We'll start with one of our colleagues and friends, Jad. He will talk about the 5G, and then we'll have two light talks. We'll open the micro for the floor, and we conclude with our comments and feedback. So, Jad, the floor for you. Thank you.
Yeah, I can see it there, but it doesn't want to.
It's already opened.
Oh, that one?
Yeah.
Yeah, okay.
Yeah, to go after the first slide.
Sorry. There we go.
Here's this microphone. Hello. All right. So, good afternoon, everyone. My name is Jad ElCham, and I work for Dataconsult. I'm the technical leader over there. And today's topic will be demystifying 5G. So, why did I choose this particular subject? Because of the reactions I was getting when I was telling the guys here and some of the participants that I'll be talking about 5G. I had a wow from Shafi, from now. Yesterday with Nishal, he asked me if that was a real thing. Some other participants thought that this is a sci-fi presentation, but I can assure you that this is pretty much real. So the things that we'll be talking about today, first we'll start about defining 5G, what 5G is and what 5G is not. And then we'll move to the use cases. The use cases is particularly what makes the fifth generation networks important. Then we'll tackle a roadmap, define the major players, and the most important part would be where do we stand here as Middle East, Levant, the area where RIPE NCC is active, where do we stand from all of this? And in between, I'll take one particular use case that might define the key differentiator for the 5G, which is the Internet of Things. Again, I'll be tackling this through the context of 5G. So, let's start. What really is 5G? If we take a look at the evolution of the way we access the internet, the way we access our network throughout the first generation, which were the analog phones, we can get to a certain conclusion. We never came up with the next generation or a new invention just because we were bored or that we had nothing to do and we had to jump from 1G to 2G. Remember, this is not Apple, this is not Samsung, so we don't have an application every year to come up with iPhone 5, 5S, Galaxy, whatever. So there's a need. Every one of these generations, of course, they had some advantages, but at the same time, they had some open caveats and some weaknesses. So for example, the second generation came in order to cater for the weaknesses of the first generation. And maybe the biggest leap we witnessed was the introduction of 3.5G. And that's high-speed internet and the app-centric experience that we face today. Now, here's a big question. Currently, we are in the middle of the deployment of 4G networks. And contrary to what we might think, 4G is still in deployment, and not only in deployment, but in development. So, what really are the weaknesses that 4G has and that 5G should address? This is the big question. Now, please keep in mind one thing. Up till today, 5G is a concept, all right? So we as the international community are in the process of defining it and standardizing it, and we'll see the roadmap later on. So, if we have this in the back of our minds, we can define two views, two current competing views of what 5G is. And remove. So the first view, we call it the hyper-connected vision. In this approach of 5G, we take it as an over-the-top layer. So we're not replacing any kind of networks. We're building on top of our existing networks. We're building on top of 2G, 3G, 4G, Wi-Fi offloading, and then the 5G will come to complement this ecosystem. The key differentiator behind this view is to actually be able to provide more connectivity, more throughput, but not the idea of the throughput as how many packets I can send, but how many connected devices I can connect to the network. And the key enabler behind it would be the machine-to-machine communication and the Internet of Things. And that's why I'll be talking a little bit about the IoT later on. In order to get to this approach, to the end of this approach, maybe a new radio technology will have to be defined. We'll see why later on. The second view would be something similar to the chart that we saw in the earlier slide, where we can say that, all right, 5G is any technology that can reach that bandwidth with that latency. So that would be a more of a traditional generation defining and not a conceptual definition for the technology. If we adopt the second view, it would be easier to define what is 5G and what is not. All right? Now, if we take a small step back, we can see that these two views, they do not overlap. And that's why it's very common for the major players in our world today to take these two views and combine them in one set, which makes it very hard to come up with what really 5G is. Again, I would say for now. So the first step on the roadmap to define what 5G is and implement it is to define the requirements that 5G should address. So the industry, back in 2012, 2013, they had a lot of brainstorming sessions, and they came up practically with 8 requirements. I'm not going to say 8 technical requirements, I'll be getting there in a minute, but I'm going to say 8 requirements. And basically they are divided into 3 axes. So we have the mobile broadband experience, right? We need to make it more extreme. Remember, 4G, what is the most dominant technology in 4G? Do you know? The LTE, the long-term evolution. So when they created it, even the name was appealing, long-term evolution. So when the guys, when they were creating the concept of 5G, they said, okay, we really need to make this really extreme. And if you take a look at the requirements that they put, up to more than 10 gigabit per second traffic, and this is not the theoretical maximum, 100 megabit per second dedicated at any point in time with an average of 1 gigabit per second traffic, and at the same time, 10,000 more units of traffic within the same coverage area. Keep this in mind. The second axis that they wanted to address was the machine-to-machine communications. Currently, right now, we have billions of connected devices, but only 2 billion users connected. And that means we have so many machines online. So these machines will need to interact between each other and exchange information. So they said, all right, we have to address this. So not only do I need to provide more traffic and more throughput for this traffic, I need to be able to connect more devices. You know that, for example, in the GSM and the 2G, we do time division and frequency division. So there are only so many people we can serve out of a certain sector on a cell. We need to get away from this idea. And that's why they said we need to have up to 100 times the connected devices that we have today. Also, we need to make our network more reliable. More reliable means 100% coverage and the 5 nines availability. Because imagine one thing, if we're talking about autonomous cars, so we have cars that drive themselves automatically, and we'll be getting there in a second as well. Imagine at one point it gets to an area where there's no coverage, even if it's a little tiny area, and chaos would happen, all right? And the key differentiator here would be this requirement there. This one and this one. Please keep this in mind. You'll see its importance. So if we take a look at these requirements, you might say that some of them, even most of them, we can achieve them with 4G. For example, if I need more traffic and more connected devices, I can add more sectors, right? If I need, for example, 100% connectivity and 99.999 availability, I can just go add more nodes on my network, and I can do redundancy and resiliency on my infrastructure. Correct, and that's why there were two views. And currently, the market is going towards defining two technical requirements out of these, which would be 1 gigabit per second traffic and sub 1 millisecond of latency. And that's the whole deal. Moving on. So, a technology without use cases is practically useless. Nobody wants to come up with a technology that we cannot apply it anywhere, right? So, the industry took a chart. On one side, they placed the bandwidths. On the other side, they placed latency. And they mapped all the possible use cases that we have today and the ones that we might need in the near future, and they all placed them here. If you take a look at it, you can see that some of the use cases, they can already be provided today, but not in an efficient way. Because try, for example, to have an Internet of Things sensor working on 3G. We'd have to change its battery twice every day. This is not efficient. So that was one of the things we need to address. Other use cases that we see over here, they can only be addressed using 5G, because the technology that we have to access the network right now, it just will not let things happen. Other use cases, they are just on the limit. So we currently can support them, but we can change their status. We can make them go on the go, not only nomadic. So a technology that is nomadic, like Wi-Fi, we would have access within a certain area. But take these services and try to extend them outside of your boundaries. Like, for example, conference calls for video. This is what 5G is trying to achieve. And if we try to narrow down all of these use cases into the most important ones, we can come up with the following list. The first use cases would be in the area of virtual reality, augmented reality, and the tactile internet. So the implications of these would be mainly in entertainment, industry, but also in healthcare. We'll be talking about healthcare in a second as well. And there's something that we are witnessing today, which is the wearable technology. This would be permitted by the 5G technology. And the second one, and which is really predominant, is the machine-to-machine connectivity. And here it's an underset of the Internet of Things. Autonomous vehicles. So we have some people around here who live in California, if I'm not mistaken. Chances are you've seen some Google cars on the streets. Basically, that's the idea behind them. But for now, Google is providing the connectivity, the wireless connectivity to these devices. Imagine now a central system inside a city that manages the whole traffic system for that city. The roads, the lights, the speeds, the obstacles, all of these. And in that case, all the cars can drive autonomously, even without a human inside them. They can drive closer to each other, and the margin of error would be reduced drastically. But in order to be able to have this, remember the 100% rule and the 99.999%? Imagine just a car without a human inside it and suddenly losing connection on the highway. Remote robotics and surgeries, and this is a hot topic, not only because my wife is a surgeon, but because experts tend to be a little bit diversified throughout the world. And back in the days, if we need a surgeon to come fly, for example, from the States to Lebanon to do, where I am, to do a surgery, that could be months apart. There was one successful operation that happened back in 2014, if I'm not mistaken. There was a French surgeon in Paris who did a remote surgery in real time for a patient in New York. But what they had to do in order to make this happen was a collaboration between Orange and AT&T, where they put fiber connection end to end. So throughout the whole ocean, and then from both sides of the connection. And this cannot happen everywhere. So, remote surgeries. And when we talk about surgeries, imagine a surgeon in Chicago doing a command and having to wait like 30 or 50 milliseconds for it to take effect on the patient. So remember the less than 1 millisecond latency, this is where it comes. And the last topic I would like to address would be the industry control and automation. So if I have all the machines on my network communicating at any point in time, I can have scripts, I can have automation enabled in a safe way in my production environment. So we said what 5G might be, we said what the reasons behind 5G are. Now I would like to address what 5G isn't. Who has WiMAX in their countries? All right. Who have LTE in their networks? Okay, so LTE and WiMAX, for example, they are 4G technologies, right? Right? Well, wrong. Wrong. WiMAX 2 is a 4G technology. LTE-A is a 4G technology. So the others, they are branding. So technically they fall under the 3G umbrella, but that's not the thing. The thing is that currently the 4G environment ecosystem is in constant development. So a lot of vendors, a lot of stakeholders, they tend to brand it as the new 5G. For example, in Lebanon, we had 3.9G. I've never heard of such a technology. We have 4G plus in Lebanon. I'm also not sure what this is. So some of the industry leads right now are the LTE advanced technology, and the network function virtualization, and the SDN, software-defined networks. So the idea of taking router switches and placing them into virtual entities, and that's the NFV. And the SDN means that we have our network being controlled and configured dynamically in order to do slicing, or for example, allocating more traffic or more links within peak times. So that's the SDN. heterogeneous networks. So when we combine different access methods with different, for example, antennas, microcells, macrocells, etc. And the low power, low throughput networks. And this is for the attempts of accommodating the Internet of Things within the 4G networks. And we'll be talking about this. This, my friends, this is not 5G. And if the vendors, if the people keep talking and keep branding these technologies as 5G, once we go to our CTOs, CIOs, or for example, our financial officers, and we say, look, we need to roll out a few $1 million to test 5G, they would say, oh, but we already have this. Upgrade your LTE to LTE Advanced, and now you have 5G. So we can understand the problem behind putting these technologies under 5G. So what are the implications of 5G on mobile operators? I'll try to be brief because Shafiq will murder me if I'm not. First of all, the operators will have to adapt to the 5G spectrum, which is still undefined for now. We do not know what bands or frequencies we'll be using. And the coverage implications. Why? Because as the industry is heading right now, they are saying that we have to explore the bandwidths between 6 gigahertz and 300 gigahertz. So the high frequencies. And within the level of high frequencies, the area that we can cover would be limited because of loss and time and space diffractions. So in this case, we'll have many smaller cells to put. So this causes coverage implications. Sorry. So maybe an operator will have to double its size of the infrastructure in order to cater for the coverage. The second one, and which would be the most important requirement, would be the sub-millisecond latency. And if we take a look at how things happen right now, at least within the LTE network, we have 10 milliseconds before we can get out of the core network of the operator. If we need to get to a certain content, provided that this content is co-located within the same country, at least we're talking about 20 milliseconds of latency. If it's outside, good luck. So how can we squeeze this in order to get a sub-millisecond latency? We have to get the content as possible, as near as possible to the user. And yes, you're not misinterpreting this. The idea right now is to get the content even available at the base station. So imagine this. Imagine that you have a much higher number of base stations and you have the content over there. Now think of implications like if there's a roamer, so someone from foreign country, and he's visiting this network. How do I get the content from there, from his home cluster, to the current one? And if, for example, we take France, they have Orange, Free, Bouygues Telecom, SFR, and all of these, they want to do that. It's going to be very hard. So there's an idea that is in discussion currently, is that in the 5G, only one network should be built. And this network will be shared by all the operators. Technically, it's feasible. Commercially, we've never seen this level of cooperation between networks. So this idea is still into consideration. So if we take a step back from the 5G and focus on one of these use cases, which is the IoT, I need you to think bigger this time. The Internet of Things, they changed from a toothbrush being like monitored by your smartphone to actually a business enabler. Take the example of Barcelona in Spain. They have modified the structure of all the city. They made it a smart city. And when we say smart city, it's not that we have internet everywhere and we have sensors everywhere. It's actually the correlation of these information and the correlation, the big data, using the big data to do something with it. So we have optimization of the garbage collection from the streets. We have sensors that would measure the lighting in the streets in order to modify the current there. We have sensors to do optimization of the traffic in the streets, everything. And this generated a $3 billion in a year. So we have to understand the economics behind it. If we take a look at all indicators, and this is taken from Cisco VNI, you can see that within 5 years, for example, we will have 10 billion additional devices connected. Just imagine the scope, the scope of maneuver that we have, the amount of information. And just between brackets, because we've seen during the last 2 days how the internet works, but what is going through the internet? Please take a look at this number. By 2019, they expect that 80% of the traffic would be video. In 2020, so that's 1 year after that, they expect that 92% of the traffic of the whole internet would be video. So ask yourselves if your network are ready for this or not. All right? And this is not, the Internet of Things is not a buzzword. Take a look in your house. 5 years, 6 years ago, you might have 2 phones, maybe not even smartphones, and 2 laptops. Now, if you're being very conservative, we can find this easily in a certain household. Okay? So the idea is taking these sensors and representing them. But how does this happen? And here we'll talk a little bit about the data flow of IoT. We have the site where we capture certain information and we code it. Then we need to get it on the network. So we have to transmit it, to get it from the radio interface up to the IP backbone. Once it is in the IP backbone, we can take it to the data center, to the cloud, where you can store it, analyze it, and do actions. And this is where the big data science, which is the new hottest topic in town right now, this is where it happens. So, where does 5G come in place? Over here. Why? Because the idea is, if I have sensors connected wirelessly, how can I transmit their chatter? Right now, there's a ferocious war when it comes to finding a new technology that does not drain your batteries. And this is something called the low power wide area war. Some protocols out there, some infrastructures like Sigfox, it's a French company, so yes, the French are quite well at this. LoRa, which is backed by Cisco and IBM. LTE-M, which is backed by Huawei. Wi-Fi on top of 3G, 4G, or Zigbee on top of 3G and 4G. So you understand now why we might need 5G in order to come and consolidate all of these and come up with something that would help solve this paradigm over here. All right? We are trying to accomplish this right now by creating a new concept like fog computing. So we're saying, okay, let's not transmit everything to the cloud. Let's bring some of the computing towards the edge. And we came up with the fog computing. But this might not work every time on every platform, because, for example, in self-driving cars, we need to be always sending the information to a central traffic management system. So in this case, fog computing doesn't work. So in that sense, we can see that the IoT comes to do the link between the information technology and the operation technology. And at the end of the day, what really counts is this over here, the dollar value. Now, we saw the use cases of 5G. We saw one particular use case, which is the IoT. Coming back to the 5G, we can set a roadmap, because we said that this is in the making. We can see that right now we are somewhere around here. We are in 2016, so we're still developing the vision. for it. And you can see as well that there are different players in the market. And if the predictions and everything goes as expected, we are supposed in 2019 to come up with the frequencies at the WRC 2019 convention. And in 2020, we hope to get the standard ready so that we can